At 6:30 on February 10, 1945, Captain Edwin Hunt stood on the west bank of the River Maas near Gennep, Netherlands, watching German artillery hammer the far shore where British engineers were supposed to build a bridge in 48 hours. Hunt was 24 years old, just 8 months removed from D-Day, and staring at a problem no army had ever solved before. 0 bridges had ever been built under enemy fire across a flooded river, while the river was still rising. The Germans had detonated the Schwammenau Dam the night before. 81,000 acre-feet of water was now tearing down the Roer Valley toward the Maas, turning a normally 300-meter river into what intelligence predicted would become a 1,200-meter inland sea within 72 hours. The flood hadn't peaked yet. It was accelerating. Hunt understood water. On June 6, 1944, he had commanded 15 Rhino ferries on Gold Beach, shallow draft landing craft that moved relentlessly through surf, tides, and cross-currents that sank less capable vessels. In 4 months, his flotilla delivered 93,000 vehicles, tanks, guns, half-tracks, and 440,000 tons of supplies to Normandy. Not a single ferry lost to tides or currents. In September, the Admiralty promoted him and sent him back to England with new orders. Report to Second Army. Chief Engineer requires a waterman. That was how Hunt met Lieutenant Constant Lambrechtsen. Lambrechtsen was 38, a Dutch hydraulic engineer with 20 years at Rijkswaterstaat, the Netherlands Water Authority. He had spent his career studying the Maas, the Rhine, and every tributary between the German border and the North Sea. He understood rivers the way Hunt understood boats. 2 days earlier, on February 8, Operation Veritable had begun, the largest British-Canadian offensive since Normandy. 50,000 men, 500 tanks. The objective was brutally simple. Push southeast from Nijmegen through the Reichswald forest, clear the land between the Maas and the Rhine, then cross into Germany's industrial heartland. But the plan depended on bridges. The Germans knew it. Throughout January, intelligence reports confirmed what Lambrechtsen already feared. German engineers had wired every upstream dam for demolition. The Schwammenau, the Erft, the Ruhr system, 5 dams controlling the Ruhr, which fed directly into the Maas. American forces tried to seize them first. They failed. On February 9th, the 78th Infantry Division finally captured the Schwammenau Dam, but too late. German sappers had blown the discharge valves and jammed the gates open before withdrawing. The reservoir was emptying at maximum flow. An 18-foot wall of water was racing toward the Maas. The British XXX Corps needed to cross at Gennep. The 51st Highland Division had just liberated the town after 2 days of house-to-house fighting. 1,200 buildings, most reduced to rubble. The Germans had destroyed both bridges, road and rail. Their twisted spans churned in the current. 10 days earlier, Brigadier Campbell, chief engineer of Second Army, had met Hunt and Lambrechtsen in a farmhouse south of Nijmegen. He spread maps across a wooden table. Normally, the Maas at Gennep was 300 meters wide. Lambrechtsen's calculations told a different story. By mid-February, the river would reach 1,200 meters, possibly more. The floodplain would sit under 3 to 4 feet of moving water. Standard Bailey bridges would fail. Fixed spans would drown. Anchored pontoons would tear loose. They needed something unprecedented. A floating bridge, one that could rise with the water, flex with the current, and stretch over a kilometer long. Campbell stared at the figures. The longest floating Bailey bridge ever built under combat conditions was 600 meters. This would require twice that length, built while the river was rising, under artillery fire. No army had ever attempted it. By the morning of February 10th, Hunt watched the Maas begin to swell. The current quickened. Debris rushed past. Tree limbs, fence posts, pieces of shattered buildings. A dead cow rolled end over end in the brown water. Operation Veritable was stalling. The Highlanders held Gennep, but without armor and artillery, they could go no further. Canadian forces were bogged down in the Reichswald. German resistance was stronger than expected. Everything depended on getting heavy equipment across the Maas. Hunt had 48 hours to build the longest floating bridge in military history, in a flood, under fire, with a Dutch engineer he'd known for 6 weeks. If he failed, 50,000 men would be stranded on the wrong side of a river that was about to become a lake. Hunt had arrived at 2nd Army Headquarters in Hertogenbosch on October 2nd, 3 days after liberation. The town hall walls were covered in maps: Maas, Rhine, Vol, every river between the front line and Berlin. Brigadier Campbell needed someone who understood water itself, currents, flood behavior, tides, not just steel and timber. Hunt's file stood out. Rhino Ferry Commander, Gold Beach, predicting tides more accurately than charts, placing vessels where others wouldn't dare. Campbell gave him an office and a mountain of data. Hunt studied the Maas for 6 weeks before Lambrechtsen walked in unannounced one December morning, carrying a leather satchel filled with hand-drawn maps. Flood levels, snowmelt cycles, ancient river channels no longer marked on Allied charts. Together, they worked through winter. Military load requirements met hydrology. Bridge sections met floodplain behavior. Engineering met instinct. By late January, they agreed on Genup. The east bank sat high. The west bank had solid approaches. A ferry crossing used for centuries proved the riverbed was stable. Even in extreme floods, the water spread outward rather than tearing a single channel apart. But Lambrechtsen warned again about the dam. If Schwammenau failed completely, the Maas would rise 15 feet or more, floating or nothing. On January 30th, Campbell reviewed their plan, checked the math twice, then turned to his deputy. "Tell the sappers at Mook," he said, "to start building 80-foot floating Bailey sections." He paused. "Keep building until we tell them to stop. We're going to need every meter they can produce." That was Hunt's answer when Brigadier Campbell asked how much bridge material to requisition, because nothing about Genup was behaving the way rivers were supposed to behave. The 51st Highland Division attacked Genup on February 11th. The Germans defended every building, every street, every doorway. For 36 hours, Scottish infantry fought through rubble, minefields, and fire. The Black Watch, the Gordons, advancing room by room through a town the Germans had turned into a fortress. Snipers fired from upper floors. Mortars dropped into courtyards. Mines detonated under collapsed walls. German 88s, firing from east of the river, slammed shells into structures that were already burning. By dawn on February 12th, the Union Jack flew over what remained of the town hall. Genup was liberated, but barely recognizable. Hunt stood on the west bank, 2 days earlier, on February 10th, watching the river rise while the fighting still raged. 48 hours before the Highlanders finished clearing the town. 72 hours before engineers could even begin construction. And the water was rising faster than Lambrechtsen had predicted. The warning had come 5 days earlier. On February 5th, a Canadian Spitfire from the Photographic Reconnaissance Unit flew low over the Maas floodplain. Flight Lieutenant Lightbody took the aircraft down to 100 feet, flying straight lines over enemy territory, his camera firing every 2 seconds. The photographs reached 2nd Army Headquarters 6 hours later. To intelligence officers, they showed flooded trenches and submerged fields. To Lambrechtsen, they showed something far more alarming. He studied the prints with a magnifying glass. The Sambeek Weir, 3 kilometers upstream, had already been scoured by autumn floods. A bypass channel had formed around it. The gates were useless. Even before the Schwammenau Dam was blown, the Germans had lost control of the water. That was good news and bad. Good, because the flood would be predictable. Bad, because nothing would slow what was coming down from the Ruhr Valley. When the dam gates were destroyed on February 9th, the flood became unstoppable. Hunt acted immediately. On February 8th, he requisitioned 140 lorries. For weeks, 7th Army Troops engineers had been building floating Bailey sections at a depot near Mook. 80-foot pontoon sections, 6 rows wide, mounted on steel flotation boxes. Each section weighed 11 tons. Each required specialized handling gear and trained crews. The lorries arrived on February 9th. That same day, the dam failed. The convoy loaded through the night. Bailey panels, pontoons, decking, ramps, anchor cables, welding gear. Every component needed to build a bridge that did not yet have a final design, because no one knew how wide the river would be when construction began. By dawn, 140 lorries stood packed into the town square at St. Anthonis, 4 kilometers west of the Maas, waiting for the Highlanders to clear Genup, waiting for Hunt's order. When the fighting ended on February 12th, Hunt crossed into Genup 2 hours after the last German withdrew. The town was destroyed. Out of 1,200 buildings, perhaps 300 still stood. Walls without roofs. Roofs without walls. The ferry house, used for centuries, was now a pile of bricks. But the approach roads remained intact. Lambrechtsen had been right. The ancient ferry site meant solid approaches on both banks, saving nearly 1,000 meters of bridging once the flood receded. Except the flood was not receding. Not for weeks. Possibly months. By the morning of February 12th, the Maas had widened to 1,100 meters and was still rising. Cold rain fell from 4 o'clock onward. February rain. Dutch mud. Everything slick, heavy, miserable. Hunt set up his command post in the remains of a riverside warehouse. No roof, 3 standing walls, just enough shelter to spread maps and protect radios. At 7 o'clock, construction began. The lorries rolled forward from St. Anthonis before sunrise. Crews unloaded immediately. Each 80-foot section required 6 men to maneuver. Steel panels locked into place on dry ground before being floated out. The plan was simple, on paper. Built from both banks. 2 crews. Meet in the middle. Standard Bailey Bridge doctrine. Nothing else about this bridge was standard. A Class 40 floating Bailey Bridge rested on pontoons, steel boxes, 4 feet wide, 7 feet long, 30 inches deep, joined into platforms. Decking laid on top. Flexible enough to rise with the water. But it could not be anchored to the riverbed. The water was too deep. The current too strong. Instead, every pontoon platform had to be secured to the banks with heavy steel cables. At 1,100 meters, that meant over 100 pontoon platforms, more than 400 individual pontoons, over 800 anchor cables. Each cable had to be tensioned exactly right. Too loose, and the bridge would drift. Too tight, and the cables would snap as the water level changed. Lambrechtsen calculated the forces: current velocity, water depth, wind load, vehicle weight. 16 pages of handwritten math. He checked it 3 times. Hunt trusted him. The first pontoon entered the water at 9:30 from the west bank. The current seized it immediately. It swung downstream as sappers fought to control it with poles and ropes. Anchor crews drove stakes into mud that barely held. Steel cables hummed under tension. It took 40 minutes to secure 1 platform. Hunt did the math. 100 platforms. 40 minutes each. 66 hours. Almost 3 days, just to position pontoons. That assumed perfect conditions. They did not get perfect conditions. The engineers kept working because stopping was not an option. If the bridge failed, Operation Veritable failed with it. The Reichswald offensive was already bogged down. German resistance was stronger than intelligence had predicted. The 51st Highland Division sat isolated in Genappe, short on ammunition, with no artillery heavier than what men could manhandle. Canadian units to the south were bleeding in flooded ground without armored support. The 30th Corps needed tanks across the Maas, and this bridge was the only way they would get there. By nightfall on February 12th, progress was brutal and slow. On the Ophelt side, engineers had positioned 8 pontoon platforms. On the Genappe side, 6 more. 14 platforms total. Roughly 110 meters of bridge. 1/10 of what was required. The rain intensified after dark. Cold, soaking rain that turned the riverbanks into mud and steel decks into ice. The temperature dropped. The Maas continued to rise. Lambrechtsen measured the water level every 2 hours. By midnight, the floodplain had widened to 1,180 meters. Hunt recalculated immediately. They would need 148 pontoon platforms, 50 more than originally planned. And the Germans had found the range. February 13th. The engineers worked through the night under generator-powered searchlights that illuminated both banks of the river. Those lights were death traps. German artillery began firing at regular intervals. Every 15 minutes. Sometimes less. The sappers learned the sounds. The rising whistle of incoming rounds. The flat crack of impact. The metallic shriek of shrapnel tearing through the air. By dawn, 21 platforms were secured. Progress, but the pace was slowing. The farther the bridge extended into the river, the harder each new platform became to control. The current was now flowing at nearly 6 knots, fast enough to tear a platform free if anchor cables were not secured instantly. At 3 o'clock, it happened. An anchor cable snapped. 6 sappers guiding a platform felt the tension vanish. The structure slewed sideways into the current. The men jumped clear just in time. The platform rolled end over end, pontoon boxes breaking apart as 11 tons of steel vanished into the darkness. 200 meters of bridge material, gone in 30 seconds. Hunt requested replacements from the depot at Mook. The answer came back cold and final. Supplies were running out. Every Allied formation was building bridges. The Rhine crossing was still weeks away, but preparations were already draining inventory. Hunt would get what was available, and nothing more. While the men worked, Lambrechtsen recalculated. By the afternoon of February 13th, the flood had peaked at 1,190 meters, wider than he had predicted, but the rate of rise was slowing. The Schwammenau reservoir was nearly empty. The flood wave had passed. That was the good news. The bad news was the wind. Forecasts showed strong northwest winds arriving on February 15th. Wind across more than a kilometer of open water would create waves. Waves would stress the pontoon platforms. Waves would make the final connection in the middle of the river nearly impossible. They had 48 hours, maybe 60. After that, the bridge might become unbuildable. Hunt pushed the crews harder. 12-hour shifts became 18. Men worked until they could barely stand, then worked longer. Field kitchens arrived every 6 hours. Tea, stew, bread. The sappers ate standing up, ate while walking, ate while driving anchor stakes into frozen mud under fire. German artillery intensified on February 14th. Fire now came from multiple directions: east of the Maas, north of Genep, south near Ottersum. German observers were clearly spotting the work. Whenever crews concentrated, shells arrived within minutes. 4 sappers were killed that day. One direct hit near the Genep shore obliterated a work crew positioning a platform. 2 men were thrown into the river and vanished instantly. 2 more died where they stood. The rest of the crew secured the platform and moved on. By nightfall, 61 platforms were in place. Half the bridge. And the men were breaking. Frostbite, trenched foot, crushed fingers, broken bones from falls on slick decking. Injuries that came not from combat alone, but from exhaustion. Then something changed. The water began to drop. Lambrechtsen noticed first. Only 2 centimeters, but it was falling. The flood wave had passed completely. The river was returning to normal flow. Platforms positioned in 3 feet of water were now sitting in 2. The anchor cables were too tight. If left alone, they would snap under load. Every platform had to be retentioned. All 61 of them. 8 cables per platform. 488 cables. Work that should have been moving forward now moved backward. Hunt calculated the delay. 6 hours at minimum. Possibly 8. Time they did not have. February 15th. Cruise retention cables non-stop. The work was technical, unforgiving. Too loose meant drift. Too tight meant catastrophic failure under load. Lambrechtsen moved from platform to platform with a tape measure and notebook, recalculating tension values in freezing spray. His hands were raw. His uniform soaked. He had not slept in 36 hours. Hunt established a relay system. Runners carried Lambrechtsen's calculations to crew chiefs on both banks. No guessing. No shortcuts. Every cable adjusted to exact specification. At 1400 hours, the wind arrived. Northwest, just as forecast. 20 kilometers per hour, rising to 30 by nightfall. Waves rolled across the open floodplain. Half-meter swells pushing from Ophelt toward Genep. Platforms rose and fell, straining against their anchors. 3 cables snapped between 1400 hours and 1600 hours. The platforms held, but only just. German artillery surged. They knew what was being built now. A bridge this long could only mean armor. The Germans poured everything they had into the site. 88s, 105s, mortars. 7 sappers were wounded that day. 2 were killed. A mortar round landed near the center of the bridge, knocking 4 men into the river. 2 were pulled out. 1 drowned before help could reach him. The bridge kept growing. By nightfall on February 15th, 78 platforms. By dawn on February 16th, 89 platforms. The 2 halves were closing in. From Ophelt, 540 meters. From Genep, 490 meters. Only 50 meters remained. The most dangerous stretch of all. The current here ran at 7 knots, strong enough to drag a man under in seconds, strong enough to rip a pontoon free if coordination failed. Hunt selected his best crews. Men who had worked since February 12th. Men who could place a platform in darkness. Men who could splice cables under fire. Men who did not panic. February 17th. The gap closed platform by platform. 40 meters. 30. 20. German shells burst continuously. Water erupted around the pontoons. Shrapnel hammered steel decking. The engineers ignored it. At 16:45, the final platform slid into place. Sappers from both banks met in the middle of the moss. They bolted the last Bailey panels together, laid the final decking, tightened the last fittings. The bridge was complete. 1,190 meters. 3,940 feet. The longest floating Bailey bridge built during World War II, constructed under artillery fire, on a rising river, against time itself. And now, at last, armor could cross. But the bridge stood alone. On both banks, the floodplain was still submerged under nearly 2 feet of water. Solid roads ended at the river's edge. Beyond them lay mud, standing water, and ground too soft to carry weight. Tanks could not reach the bridge. Trucks could not approach it. Nothing heavy could cross. The engineers had built a bridge to nowhere. They had 72 hours to change that. 72 hours before Montgomery's headquarters demanded results, and before German artillery finished what the river had failed to do. Causeway construction began immediately. The floodplain was drying, but far too slowly. 2 feet of water over soft clay was a death trap for vehicles. Engines would flood. Tracks would dig in. One stalled tank would block the entire crossing, turning the bridge into a traffic jam under artillery fire. Hunt ordered temporary roadways built across the flooded ground. Crushed stone, gravel, Bailey bridge panels laid flat to spread the load. Anything that could create a solid surface. The work was brutal. Lorries dumped tons of fill material directly into standing water. Sappers spread it by hand. Shovels, rakes, boots sinking deep into mud with every step. Men worked soaked to the waist in freezing water, hauling stone, leveling ground that tried to swallow it. On the Ophelt side, the causeway needed 200 meters of fill. On the Ginnop side, 170 meters. Both had to support Churchill tanks, 40 tons each, the heaviest armor the British Army fielded. If a tank broke through the surface, it would sink. The crossing would stop. Everything behind it would be trapped. Lambrechtson calculated the load-bearing requirements. 6 inches of crushed stone minimum. 8 inches where the mud was deepest. Compacted, graded, with drainage ditches on both sides to carry water away. Precision work, in conditions where precision barely existed. On February 18th, German artillery shifted targets. The guns stopped concentrating on the bridge itself and began hitting the causeways. Shells fell among the work crews. Explosions blasted mud and gravel into the air. Craters opened in freshly laid roadway. Crews filled them, dumped more stone, leveled, and kept moving. 6 sappers were wounded that day. 1 was killed, shrapnel from a mortar round. Medical teams evacuated casualties across half-finished causeways. Stretchers carried through ankle-deep water. Wounded men loaded into ambulances bound for the field hospital at Boxmeer. By nightfall, the causeways were 70% complete, but the bridge itself remained untested. No vehicle had crossed it. No one knew if the pontoons would hold under armor. No one knew if cables would snap, or if the current would twist the structure apart. Hunt ordered a test crossing. February 19th, 8 o'clock hours. 1 vehicle, a single jeep, for men. If the jeep crossed, heavier vehicles would follow. If it failed, the bridge was useless. At 8:15, the jeep rolled onto the bridge from the Ophelt side. The driver held a steady 10 kilometers per hour. The deck swayed. Pontoon platforms rose and fell beneath the tires. Cables creaked. Steel groaned. 50 meters. 100. 200. At 8:20, German artillery opened fire. Shells splashed down on both sides of the bridge, throwing up towering columns of water. The jeep did not stop. Halfway across. 300 meters to go. The Ginnop bank came into view. At 8:32, the jeep rolled off the bridge onto the Ginnop causeway. 17 minutes to cross 1,190 meters. The bridge had held. Hunt immediately ordered heavier vehicles forward. A 3-ton lorry crossed at 9 o'clock. Then a 5-ton lorry. Then a universal carrier. Each vehicle stressed the bridge more than the last. Each crossing proved the structure could bear the load. By noon, 20 vehicles had crossed. By nightfall, over 100. The bridge was operational, but not yet official. Montgomery wanted to see it. Churchill wanted to see it. The Prime Minister and the Field Marshal were coming to Genappe. If the bridge failed with Churchill standing nearby, no engineering success would matter. Hunt had 48 hours to make absolutely certain it would not. February 20th. Final inspections. Hunt personally checked every pontoon platform, every anchor cable, every connection. Lambrechtsen remeasured water levels. The floodplain had dropped another 10 centimeters overnight. That meant more adjustments. Crews retention cables again, working through the morning. At 1400 hours, the first heavy armor crossed. For Churchill tanks, single file, 30 meters apart. The bridge sagged visibly under the weight. Pontoons dipped lower into the water. The structure flexed, but it held. More tanks followed. By nightfall, over 200 vehicles had crossed the Maas. Tanks, self-propelled guns, ammunition carriers. The bridge carried them all. February 21st, 11 o'clock hours. Winston Churchill arrived on the West Bank, accompanied by Field Marshal Montgomery, Field Marshal Alan Brooke, and Lieutenant General Miles Dempsey. The senior leadership of Britain's war effort stood watching armor roll across a bridge that had not existed 9 days earlier. Hunt and Lambrechtsen stood nearby, exhausted, unshaven, uniforms stained with mud. Neither had slept properly in days. Churchill asked about the timeline, asked about casualties. Hunt reported, 8 sappers killed, 23 wounded. Churchill nodded, looked out across the bridge, called it magnificent work. Montgomery walked partway onto the bridge, inspected the pontoons, examined the cable system, stood within meters of a Churchill tank as it passed. The structure swayed beneath him, but remained steady. When he returned to the bank, Montgomery told Hunt the bridge had saved Operation Veritable. In 8 days, under artillery fire, in flood conditions, across a river that changed level by the hour, the engineers had built 1,190 meters of floating Bailey Bridge. The previous record was 555 meters. This bridge was more than twice that length. The causeways continued to improve as the floodplain dried. By March 1st, the crossing supported continuous traffic, day and night. Armor, artillery, supply convoys, all flowing east. Operation Veritable concluded on March 11th. German forces were pushed back to the Rhine. Montgomery turned his attention to Operation Plunder, the Rhine crossing itself, made possible because bridges like the one at Genappe kept the offensive moving. The bridge remained in service long after the war. A permanent replacement was not completed until 1955. For 10 years, the Bailey Bridge carried civilian traffic, reconstruction equipment, and the materials that rebuilt the Netherlands. A bridge built for war became a tool for peace. Hunt was promoted to major. After the war, he returned to England, taught navigation and rivercraft, and was appointed Queen's Barge Master in 1978. He died in July 2022, aged 102. Lambrechtsen returned to Rijkswaterstaat, spending decades rebuilding the Dutch flood control system destroyed by war. A memorial was unveiled at Genappe on May 11, 2022. Hunt attended. He stood where the bridge had once spanned a flooded river, where 8 men had died, where an impossible problem had been solved with mathematics, steel, and resolve, and where a river that was meant to stop an army failed.